behalf of GIFSA-CRAFTS, a student-driven research initiative of Government Institute of Forensic Science, Aurangabad. The vision of this research hub is to harness the power of mind, driven by research, innovation, creativity, and critical thinking for smart and reliable forensic solutions. And to accomplish this vision, our missions are to inculcate the innovation research processes based on creative and critical thinking, to explore the new avenues of research in forensics by ideating, prototyping, and testing, to collaborate with various organizations for innovative solutions related to forensic problems. Presently, we have 4 different wings in our research hub, namely event management that will be looking after organizing of different events. Next wing is publication that will be looking after publishing of newsletter, articles, etc. We have another wing called as research linkage that will engage in research collaboration with different organizations. Again, we have IT management wing that will be with us with IT support and will handle all our social media platforms. The initiative has been taken to promote research culture for betterment of the society. So today, to add up to our research knowledge, we have with us Dr. Joy Adserias-Garriga. Ma'am is a forensic anthropologist and forensic odontologist from Spain, where she directed and lectured in different postgraduate programs in forensic science. She was an external advisor to Catalonian police, who in turn honored her with a police decoration for her contribution in forensic casework in anthropology and odontology. Ma'am worked as a forensic anthropologist in the identification of bodies found nearby the border between Mexico and US in South Texas at Forensic Anthropology Center, Texas State University. She has conducted research collaborations with different entities in the United States and Europe. She is a member of the American Dental Association Standard Committee on Dental Informatics, Forensic Odontology Informatics. She is a diplomate of the American Board of Forensic Odontology, and she serves as a member of board governors in the American Society of Forensic Odontology and as a member of board of directors of the International Association of Coroners and Medical Examiners. She is a member of the Interpol Disaster Victim Identification Odontology Working Group and the Interpol Disaster Victim Identification Pathology Anthropology Subworking Group. Dr. Adserias-Garriga is an assistant professor of the Department of Applied Forensic Sciences at Mercyhurst University. I welcome you, ma'am, to this session and I would like to make a note that if any attendees have any queries, you can type your question in the comment box and the answers will be given by ma'am. So now over to you, ma'am.
Well, first of all, I would like to thank you. It's a really, really great initiative, so I really applaud that. Let me share my screen with you. It will take a minute, sorry. So in this session or in this time, I'm going to be talking about all the applications of forensic anthropology, and I'm also going to talk a bit about forensic odontology in the research that I conducted and also in the casework. So I think that for many people, the first thought that they have when they think about forensic anthropology, it's one of those TV shows. Unfortunately, I have to say that there are so many things that appears in the shows that we cannot do. And for sure, there are so many things that we cannot do as fast as they appear in the shows. For some other people, maybe the image that they have for forensic anthropology is this one. So it's a scientist that always stays in the lab and just deals with dry bones. And let me tell you that nowadays, forensic anthropology is much more than deal with a box of dry bones. In the present times, there has been a paradigm shift, as Dr. Dickmat stated in this article by him, Luis Cabo, Steve Osley, and Steve Sims. And in this article that was published already in 2008 shows all the new the new perspectives of forensic anthropology. We know that nowadays the case does not begin in the lab. Every case begins at the scene. So the scene recovery techniques are going to be very, very important for not to lose information. And also we are developing new techniques, and these new techniques are allowing us to develop new methods for our estimations and our conclusions. And in the present times, because of all these new technique developments and new methods, we are required to give our conclusions that are all science-based. And that's how we have to look forensic anthropology nowadays. I'm going to talk about what we do in Mercyhurst University. We are a team of 7 faculty already. We are under Dr. Dickmat, and we have different specialties. We conduct cases, we carry on research projects, and we do this at the same time that we are training the next generation of forensic anthropologists. So that's what I'm going to talk in this time about cases, about research, and about training. Forensic anthropologists are required when you have any kind of violent death, even if it's it might be an accident, or it might be an homicide or a suicide. Any case where we have unidentified bodies, and of course it's so needed in mass disaster scenarios. Especially forensic ontology in mass disaster scenarios plays a very key role. And there are going to be 3 basic questions that we are going to be asked. We are going to be asked about who that person is, and we're going to try to achieve an identification through all the identification methods. We're going to be asked about how that person died. And there are some times that we can make an approach of how that person died through trauma analysis. There are some times that we cannot state any cause or any manner of death or any evidence that it's linked to the death of this individual. And also, and maybe that's, no, for sure that's the most tricky question, we are going to be asked when that person died, and that we are going to try to estimate the time since death through all the techniques and methods that we have for postmortem interval estimation. So the first thing that we have to do when we have a body that it's an unknown, we have to identify that body. The first thing that we have to look at if it belongs to a set of bones that are human or non-human. And that's very easy when we have the remains like complete skeletal or anatomical elements, like can be a cranium or can be a femur, whatever one we have. The difficulty comes when there are fragments, and that can be more difficult, but it should be something that forensic anthropologists, we are very good at differentiating non-human bones from human bones. So if the bones or the remains are human, next time we have to do it's to estimate or trying to estimate the ancestry. Sometimes this is not possible, but in the time, I mean, in the cases that it is possible to estimate an ancestry, we can do it through certain observation of the cranium. We're going to be focused on the cranium for the estimation of ancestry, and we can also use some softwares that are developed for ancestry estimation specifically, and it can help you with the sex estimation stature, like it's 4Ds by Steve Osley and Jans. So this software 4Ds will give us an estimation of the most likelihood of group individuals that individual belong to. So we also have to estimate sex or diagnose sex, and we have to focus. We always focus traditionally on the pelvis. So all the pelvic region, the os cox especially, it's going to be the first election or the first observation for sex. We can also rely on the cranium and some cranial features that, of course, for females are going to be more gracile than for males. They're going to show more robusticity, and that will happen in the whole skeleton. We can also rely on sex. We can also rely for sex on the measurement of the postcranial bones. That sometimes that it's working so well. Regarding age, so when we are young, we can rely on our growth and development. But when we are adults, what we have to rely on is on the degenerative changes of our skeleton, on our bones and our teeth. So we can use the pubic symphysis, as you can see here, all the changes that it has. So at the beginning, it has this nice billowing and a nice contour. And when we advance to age, this is all like this all structure. It's quite flat and some bone lipping appear because of age. Another structure that we can rely on, it's the auricular surface. And so we are here in between the articulation, in between the os coxa and the sacrum. And what we're going to look is this area here, which we call the auricular surface. So we are going to see there are softer billows. There are sometimes when we are advancing in age that some bone pitting appears, porosity, microporosity, and some exostosis will appear, and as well as some bone lipping at the edges. So this is what we are going to look at in the auricular surface, and that has been used for so many years. So it's widely used and very useful and very accurate for age. We can also rely on the cranial sutures, although the cranial sutures they have a big limitation, which is they give us a very, very big range of age. So it can be used in conjunction of other age estimation, age indicators like the os coxa, but just alone sometimes gives you a bit of uncertainty. We can also rely on the shape that we have in the sternal surface of the ribs. And we can see here that we go from very nice shape, very rounded shape, to those, let's say, like crab leg shapes here, with bone lipping again, with and we can have like some like bone porosity all the way in the bone also. And this has been shown to be quite accurate in the estimation of age. So it's another age indicator that we can use. And also for age, we can use our dentition. And there's so many changes that our dental structures go through just because of age. So we can have attrition or dental wear. So the dental structure will be more wear when we advance in age. The tooth color will change also, and we will have always a periodontal recession just for age, not only for pathology that it could be affected, but also for age. And then there's some changes in the root, like the root resorption or the cementum apposition, and very especially the root translucency. So there is a translucency that is growing and growing in the tip of the roots, that it has been used for age estimation. So what we are measuring is this part here, where we can see the translucency in the root. So Prince and Jubelacker develop different formulas for the different ancestry. So here we have the male African ancestry, and we have a formula with the standard deviation that will give us the estimation of age through certain measurements. So we will measure the root translucency here, the periodontal recession, and the height of the roots itself. So that was a method that has been used for several years. It has been worked pretty well, but we didn't know what amount of light we have to apply to the tooth to be able to have the best estimate. So some years ago, we published this article where we were setting the light conditions for measuring the root transparency for the age at death estimation. And this is something that nowadays we apply in all casework, because we said that the best amount of light is 1,600 lux. And with this condition of light, we have the most accurate dental age estimations. Then we can estimate the stature doing several metrics. So we are going to measure several bones. We can measure some long bones, or we can measure all the bones that will contribute to the stature, if we have them in the remains that we recover. So once we know that it's a human, its ancestry, its sex, the age, and the stature, we are having broad description of the individual. So we can tell the law enforcement or the authorities that we are working. We are looking for a man that is between 35 to 50 years old, that was like in between 5 foot to 5'9" of stature, and with all this description, normally the police agencies or the law enforcement agencies that we're working, they will give us some candidates for this identity. At that stage, what we have to do, it's a comparison, and we have to compare the postmortem data that we have. The postmortem data is the results of our examination of the remains, and we have to compare them with the antemortem data that the law enforcement will give us. So here for the comparison in between the postmortem and the antemortem data, we can use anthropology. We can use the comparison of certain surgical devices, for instance, that we get from a radiograph. But in my opinion, the main role in the comparison between postmortem data and the antemortem data for the identification of the individual, it has the odontology. So forensic odontology, it's a very fast way, very expedited way way of identify an individual by scientific means. We have to think that our dentition and our restoration are preserved so much to the decomposition process and many external factors that may affect the soft tissues, of course. And we also know we have a lot of information in one mouth. Just looking at one oral cavity, we have 32 teeth, and each teeth have 5 surfaces. So we have the buccal, the lingual, the 2 interproximal, and the occlusal one, or the incisal one. And that means that we have 160 surfaces where we can find a potential peculiarity, a potential individualistic characteristic, as it could be a filling, or it could be an anatomical variation. But that's just looking at the oral cavity macroscopically and direct visualization. If we do, if we apply if we take X-rays to that oral cavity, then we have so many other features that we can rely on, like the root canal morphology, or the bone trabecula, and along, etc. So forensic odontology nowadays is widely applied in daily forensic cases, and it's also very important in disaster victim identification. Regarding the second question about how that person died, we are going to try to answer this question. And as I told you before, there are many times that it is not possible. But the times that we have some trauma signs, we can conduct a trauma analysis. The 2 main things that we want to know when we have any sign of trauma, it's the cause of trauma. So we have, we have blunt force trauma, sharp force trauma, and gunshot defects. And also we can have the thermal trauma, or the fire-related or heat-related transformation of the skeleton just because of the heat. And something really important to answer in trauma analysis is when that trauma was caused. So it's going to be very different if the trauma was caused antemortem, was perimortem, or postmortem. So antemortem for forensic anthropology means that trauma was caused quite long time before the death. And we're dealing with heel fractures, for instance, heel trauma, all the heel fractures will be very useful for identification rather than for analyzing the trauma that has any event that was related to the death. The perimortem trauma, it's going to be the trauma that it happened around the moment of death. And what we will see is that it won't have any show of bone remodeling. So the bone didn't have the time to heal. Okay. And then a postmortem damage will be seen as a taphonomical effect, and it should not be confused with a perimortem trauma. So depending on the characteristics of the defect, so depending on if it has beveling, the fractures that has related to the main defect, we can figure out if it's a gunshot wound, like in this case, or it is a blunt force trauma or a sharp force trauma. So depending on the characteristics that we see in the skeletal defects, we can figure out which kind of trauma. And this is a field that in forensic anthropology has gained a lot in the last years. There are so many cases that forensic anthropologists are just called to conduct the trauma analysis. So there are cases that the individual is already identified, they know who it was, but they really want to have a very accurate analysis of the trauma signs. And the best way to do that is through the skeletal elements, through the signs of trauma that we can see in the bones. And as I told you, in the last years, trauma analysis has gained a lot of the importance of the forensic anthropology capabilities. Let me show you a case that I had in Spain some ago. This is everything that we found. So we found a cranium and a mandible. We found a femur, a tibia, and an os coxa. So you can think that this is not a lot, but if you know where to get the information from, it can be very informative. So as you see here, the cranium had a defect in that temporal bone that was caused by a gunshot. Through the auricular surface that I talked to you about some minutes ago, we could estimate the age. Because of the overall shape of the os coxa and also the metrics of the femur, we could figure out there was a male individual, and also excuse me, and also because of the metrics of the femur, we could assess the stature, and we had the cranium, so we could assess the ancestry too. So we just with these three bones, we could have the biological profile of the individual. Then I was analyzing the trauma, and you could see here the defect on the bone and the beveling. So the beveling on the gunshot trauma is a very accurate indicator of if the gunshot defect is the entrance or the exit. So we had that defect here that was the entrance, and all this defect here that was the exit. And we also found, and this is something that I found very, very, very frequently in gunshot wounds in the cranium that had like a mesial, distal, or distal mesial direction. I find very, very often the fractures in the mandible condyle, very, very, very frequent. So we could do a trauma analysis, and our results were that it was a perimortem gunshot trauma. We had some fractures, of course, for the defect for the gunshot, and also some fractures in the nasal bones, and because we couldn't find an identification or an identity for this individual, I contacted with a forensic artist that just reconstructed all the parts that were damaged, and conducted the whole forensic facial approximation. This artist was Phyllis Frost, and it's a brilliant forensic artist, and it's always a pleasure to work with him. So this is the final sketch that we got. Regarding the thermal trauma, the trauma caused by heat, we can have irradiating heat, and we can have fire flame. And so the defects in the bones or the alterations in the bones and the teeth are very different. So we have the bones become like brownish and then become like black color. And then when they are calcinated, they become very like, let's say, light gray, and finally a chalky white color. We also know that apart from the color changes, the bone shrinks, and the bone will go on several deformations. So the shape of the bone will be altered, and there will be some fractures that will be caused by the fire. And it's very important to differentiate those fractures that are caused by the fire, and they are like they are something that it's going to be logical to see in burn remains, than the fractures that are not caused by the fire. And that's very important. It's in that aspect, it's really, really important to have specific training on burn remains. So in a research that I conduct in Spain, I was analyzing the cremates. So I was analyzing the remains before and after to be cremated in the crematorium, in the retort. So I could see all the fractures that we can see in the bones and the teeth. And we apply all this knowledge in Caseworks. And let me share with you this case that we had some months ago. There was a fire scene where some burned bones were found. And here I can tell you that the success of this case and the success of so many cases in fire scenes is the good recovery. So here you can see our master students of Mercyhurst University, Anthony Lanfranchi, Victoria Lamont, Elizabeth Brooks, that are like a very, very good asset in our team. They are brilliant students, and we could not conduct all the work that we are doing without them. And so we went to the field, and we were recovering all the bone and teeth and all the skeletal material that we found in the scene. And this is the parts that we have recovered. We had some charred bone that it's shown in black. There were some bone that were like calcinated, and there were some parts of bone that were not very altered by the fire. So it has been burned, but there are some regions, some skeletal regions that were not that were more altered than others. And just I want to pay attention on this mandibular fracture, on these mandibular fragments. Here you can see the coronoid apophysis and the coronal process and the condyle, and this is the ramus of the mandible, and this is part of the body. So this is altered by the fire, but all this part of the bone, it's not. And we can see this fracture that has all the characteristics of a perimortem blunt force trauma. And so sometimes when we are dealing with burn remains, you have to pay attention, because sometimes the fire, it's you don't have to just analyze the pattern of burning, but you have to be very, very, very aware that sometimes the fire, it's used to hide some other evidence, as it was in this case. And finally, the last question regarding a scenario where forensic anthropologists are required will be when that person died. And let me tell you that this is the most tricky question that we can be asked. It's from the three of them, the postmortem interval estimation is the most difficult one. So traditionally, we have relayed some decomposition states to some time intervals. So a fresh state in the traditional approach was 1 day to 1 week. Then we have the discoloration stage that we have from days to a week, and then we have the bloat stage, which we have an active decomposition, an active decay, when it can start 48 hours after the death, or an advanced decomposition where we have an advanced decay that can be weeks after death. And finally, we have the skeletonization of the remains that in the traditional approach was around months after the death. However, if we look at this graphic, we can see the loss of mass here when we are decaying on the surface, and we can see the loss of mass of the remains when we are under soil. And if we're decaying, if we are decomposing, if we are carrying out the decomposition in water, probably the curve will be like here. So it depends a lot on the environment that we are decomposing, how we are going to decompose, and what are going to be the timings of the decomposition. So we have seen that this approach nowadays, it's not always accurate, and it depends on many factors: external factors from the environment and internal factors from the body itself. However, we have developed some methods and we have used some techniques to estimate the time since death. We can rely on the physical changes, on all the changes in the chemistry of our body by the autolysis and the thanatochemistry, and that's all related the chemical changes in our decay. We can also rely on taphonomy, and that's something that it's very useful to have an orientation about the time since death for all the changes through taphonomy, regarding how the scavengers have altered the body, how much skeleton we have exposed, etc., etc. And then we can have like some environment cadaver exchange studies that have been conducted. And also, as you may know, we can use the insect activity. So forensic entomology can be used for estimate time since death. However, the moment where the flies are putting our eggs on our body, it's something that it's changing in the several seasons, and we have an elapse of time that we have a lot of uncertainty in between when the death happened and when the first flies came and put their eggs. So in the last years, an approach that we have been exploring is using the bacterial activity. So using microbiology and all the microbes that we can find along the decomposition process to estimate time since death. And I think it's a very good approach because, as I told you, we have an elapse of time until we die and the first fly access to the body and puts the first eggs. But the bacteria that are initiating all the decomposition process, and they will have a very important role in the decomposition process, are already in our bodies, because the bacteria that initiate the decomposition process are the same bacteria that we carry in our bodies when we are alive. So we developed two studies until now that are published, and we still go on researching this field of forensics by using the microbial changes in the body and the soils. So we did an approach through the oral microbiota. So this is exploring the time since death or the postmortem interval estimation through the microbiome that we have in our oral cavity, in the surface of our teeth, our tongue, and in our jaws when the soft tissue has gone. And we had another approach regarding how to estimate time since death, that it was the changes in the microbiome in the soil around the cadaver. And this is the results that we have when we are analyzing soils. And you can see so many colors, and you can see so many changes, and there's a lot of data in there. But what I'm going to ask you to look at, it's just the changes in the colors, okay? So here you can see that it's the beginning of decomposition, and here is the last stages of decomposition. Same here, this is an individual and this is another individual. We are here at the beginning of the decomposition and here at the end of decomposition. And you can see that we have a pattern of changing of how the colors are changing. So here the yellow will be at the beginning, but not at the end. Same here, the yellow is at the beginning and not at the end. And this light green, it's very seldom found at the beginning, and it's very, very common at the end. So, and you can do that with all the colors, right? So all these different colors are representing different groups of bacteria. So you can see that there is a tendency of certain groups of bacteria to be present at this early stages of decomposition, and they are disappearing at the end of the decomposition. And remember that this is soil samples. So what is happening here is that at the beginning of decomposition, we have much more diversity than at the end. And all these groups of bacteria are soil representative. So are representatives of the soil. So there are bacteria that were in the soil before the cadaver was placed in. And as the decomposition advances, we can see that there is a next change or a transfer, like better say a transfer of microbes from the body to the soil. And that's what we can see here. So these representatives up here are representatives that are coming from the body, and they are colonizing the soil. And they are displacing other groups like the Acidobacteria that are like more representative from the soil rather than the body. When even we could develop a curve estimating the time since death in days. However, this result just can be applied in the conditions that we developed our experiment. So that was conducted in Tennessee in the Firmicutes, which is one of the groups of the bacteria that we looked at. It's just going to be applicable in cases where we have the same environmental conditions. So a lot it's still to researching in this area. It's a lot to be researching yet. And this is the same thing that we got, but instead of looking at the soil, we were looking at the oral cavity. And we have less background noise, let's say. So we have less groups of bacterial representative, and maybe that's quite easier to analyze. So we have this group of bacteria, the red ones that are represented by red, that are present at the beginning, and they are like quite disappearing, and then they appear again. And that's because all the environmental conditions regarding the oxygen availability and the pH and all the environmental conditions that are changed by the group of bacteria that are colonizing. So what we have in the last 15 years is that we had an absolute metamorphosis in the methods or in the approaches of postmortem interval estimation. We went from subjective and qualitative methods to the nowadays objective and quantitative methods that we are developing. However, as I told you, this research is still a long way to go. We need more reproducible methods. We need larger sample sizes. We need to test it in different environments, and so we are in need of lots of research in that field. So those are the basic questions that we have to answer in all the forensic anthropology and forensic odontology casework. And I would like to remark and highlight that the case always begins at the scene. So the importance of the techniques applied in the recovery of the remains are going to be key in the studies that we are going to conduct afterwards in the lab. We have to conduct very good practices in the laboratory using methods that have been accepted scientifically. And something that it's really challenging, and it's really exciting for all the people that we are doing casework and are in the academia context, is that our cases sometimes bring us questions that we can answer conducting research projects. And that's very, very exciting. But the only way we can do that, all this in a proper way, is having a specific training. So we have to be specifically trained in the analysis of burn remains. We have to be specifically training on time since death estimation methods and trauma analysis and taphonomy and so in different fields. So for me, the base of everything, it's a specific training in forensic anthropology and forensic odontology. So we have new technologies nowadays, and we are conducting online courses that you can find in this entity, like HD Forensics. We're conducting forensic archaeology, especially with the recovery techniques, forensic odontology, fatal fire and mass disaster scenarios, and also a course on DNA. So there are online courses. That means that this is accessible for everyone. Anybody that can be anywhere around the world can have this nice training. And HD Forensics is going to launch the first virtual reality courses in osteology, forensic anthropology, and forensic odontology. That's going to be happening in, I think, in 2 or 3 weeks' time. So check that out, because it's accessible to everyone. This is everything that I wanted to talk about today. So if you have any question, absolutely feel free to email me. As you have seen, I hope you have seen, I'm so dedicated to forensic sciences, and it's my passion and it's my vocation. So I'm always welcome to people to contact me for any question that they have or any concern that they have in forensic science. And I want to finish thanking, a big thank you to GIFSA-CRAFTS for allowing me to share all this with you. Thank you so much.
Thank you, ma'am, for the inestimable information. We have some queries from our attendees. Ma'am, if you permit me, I would like to put forward those queries.
Oh yeah, sure.
Ma'am, the first question is, can we use microbial forensics along with forensic anthropology to determine postmortem interval?
Yes, I mean, we are working on that. So it's not a method that we can apply, or that we are not applying in a daily forensic cases, because we are still developing until it can be used for forensic cases. So now what we call the thanatoomicrobiology, the microbiology regarding the postmortem interval estimation studies, it's in a research stage. We are working so hard to be able to upgrade it and be able to make it possible to apply it in forensic cases. However, it's not like it's not something that we use in a daily cases.
Yes, ma'am. So, ma'am, our next question is, can you name some softwares that can be used for postmortem interval estimation using anthropology?
There are not softwares. We have no softwares for forensic, postmortem interval estimation, because we don't have set yet all the let's say like the conditions that we have to conduct our experiments. So once we have this, then the developing of softwares, it could be useful. We have softwares for ancestry estimation, sex estimation, stature estimation, dental identification. We have lots of softwares, but for postmortem interval estimation, we use softwares to develop our conclusions, but there is no specific postmortem interval estimation software nowadays.
Okay, ma'am, thank you. So as there are no more questions, let me conclude the session. GIFSA-CRAFTS team is thankful to you, ma'am, for giving us time from your busy schedule and enlightening us with your immense informative talk. I also thank Director Sir of the Government Institute of Forensic Science, Aurangabad, for his valuable guidance and support. I also thank all our teachers, staff members, and students for being with us in every part of this initiative. I would like to make a note that if any organization wish to collaborate with us, we'll always welcome you. And last but not least, thank you everyone for attending this session, and hope to see you all soon again. The link for feedback form will be given in our YouTube and Telegram channel, and it is mandatory to fill it in order to get the certificates. Also, the certificates will be provided to all participants through our Telegram channel. Again, thank you so much, ma'am, as well as all participants for being with us. Thank you.
I really thank you, and I wish you all the best in the future of forensics. Thank you so much.